In this video, we will learn about the bonding in carbon compounds. So it must be noted that all the organic compounds contain not only carbon but hydrogen as well. It is also true that organic compounds may contain certain other elements like oxygen, nitrogen, chlorine, bromine, etc. Carbon with atomic number 6 has the electronic configuration 2, 4. It means that carbon has 4 electrons in its valence shell. So now, how can carbon atom attain the octet configuration means how can it become stable? So there are two cases. First is it could gain 4 electrons from other combining atom forming C4 minus anion, but when it gains 4 electrons it would be very difficult for the nucleus of carbon atom, which is having just 6 protons, to hold on to 10 electrons. So this would not be stable. Next, it could lose 4 electrons forming C4 plus cation, but again this will be very difficult because it will require a large amount of energy to remove 4 electrons from an atom, and such a large amount of energy is not available during a chemical combination. Now, as carbon cannot form anion or cation, the organic compounds are not ionic in nature. This is also proved by the fact that organic compounds are bad or poor conductors of electricity. So now what will carbon do? So carbon attain its octet configuration by sharing its valence electrons with other combining atoms. Thus, organic compound involve covalent bonding. For example, let's see formation of methane, that is CH4. So in CH4 we know carbon has 4 electron in its valence shell and hydrogen has 1. So carbon atom share its 4 valence electrons with 1 electron each of the 4 hydrogen atom, as we can see here. So each of the hydrogen gets its duplet complete and the octet of the carbon atom is also complete. So in this way, both carbon and hydrogen acquire the nearest inert gas configuration, and as we can see that there are 4 shared pair of electrons between carbon and the 4 hydrogen atom. Therefore, we can say there are 4 single covalent bonds between carbon and the 4 hydrogen atoms. Now, we can see here the formation of ethene, that is ethylene C2H4. Now in ethene, the 2 carbon atoms are bonded together by a double bond, and each carbon is bonded to 2 hydrogen atom by a single bond. As we can see here, the octet of both the carbons are complete and the duplet of hydrogen is also complete. So here a double bond is formed. Next, in acetylene or ethine, that is C2H2, molecule of ethine has 2 carbon atom and 2 hydrogen. Now out of the 4 valence electron, each carbon shares 3 electrons among themselves, forming a carbon-carbon triple bond, and each carbon atom shares its fourth valence electron with 1 hydrogen, forming a CH single bond. So here we can see that ethine molecule has 1 triple bond and 2 single bonds. So this is how we can see that organic compounds are formed by sharing of electrons. Now let us talk about the unique nature of carbon atom. So we know that the number of carbon compounds are very large. There are a lot of carbon compounds existing. This outnumbers by a large margin the compounds formed by all other elements when put together. So almost 90% of all known compounds are organic in nature. Now the question is that why is the number of carbon compounds so large? Now there are certain factors because of which carbon is forming so many compounds. First is catenation. Catenation means linking of identical atoms together to form long chains. Now carbon atom has the maximum tendency of catenation. A large number of carbon atoms link with each other to form long chains. Now these may be straight chain, branched or cyclic chains. Now because of this property of catenation and the carbon-carbon bond being stable, carbon is able to form a very large number of compounds. Elements like sulfur, phosphorus, oxygen, silicon also show the property of catenation, but less than carbon, means carbon shows the property of catenation to the largest extent. Silicon, which is the second member of carbon family, forms compounds with hydrogen which have chain up to 8 atoms, but these compounds are very reactive. In addition, carbon atom may be linked by a single, double or triple bond. So any type of covalent bond can be formed by carbon atom. Next is tetravalency of carbon. Tetravalency means carbon has a valency of 4, so it is capable of bonding with 4 other atoms of carbon or atoms of other elements. Thus, compounds of carbon are formed with hydrogen, oxygen, nitrogen, sulfur, chlorine, etc., which is giving rise to large number of compounds. Also, the bonds that carbon is forming, they are very strong, hence the compounds are stable. And the reason of this strong bond formation is because of the small size of carbon atom. Next is isomerism. So there are different compounds which have the same molecular formula and molecular mass, but they have different arrangement of atoms present. These compounds are called isomers, and the phenomenon is called isomerism. For example, the molecular formula C5H12 accounts for the 3 different compounds. Here we can see that all the 5 carbon are arranged in a straight chain. It is called N-pentane. Here 4 are arranged in a chain and 1 is branched. So this is isopentane. Here 2 carbons are branched. This is neopentane. Similarly, molecular formula C3H6O account for 2 different compounds which have different physical and chemical properties. See, the formula is same C3H6O, but one is propionaldehyde and the other one is acetone. So these are called isomers. So I hope it is clear to you. Thank you.